All right. If you want to follow me on Twitter, you can find me at SteckFIS, where I will post topics and links for the videos that I've made. Today we're going to talk about divisibility rules. These are rules to use to help you find if a number is divisible by a certain number and to help you find factors for a number. Now, even with these rules, it's important to spend time learning your multiplication facts. It will save you time in the long run and will make your future math much easier. So let's look at this first one. Divisible by 2. All right, well, the rule is if the number ends with a 0, 2, 4, 6, or 8, it is divisible by 2. So let's look. What digit or number does that end with? It ends with a 6. All right, is 6 on our list? 0, 2, 4, 6. Oh, yep, it is. So that one is divisible by 2. It doesn't matter at all what these other digits are as long as it ends with a 0, 2, 4, 6, or 8. Now let's look here. 63. All right, what digit does it end with? It ends with a 3. Is that on our list of 0, 2, 4, 6? Nope, it is not. So that one is not divisible by 2. All right, so now let's look to see divisible by 3. The rule: if the sum of the digits is a multiple of 3, it is divisible by 3. So we take each of the digits here. So we have a 3, a 4, and a 5. And we add all of those together. So that would be 3 plus 4 plus 5. So 3 plus 4 is 7, plus 5 would equal 12. Okay, so is 12 a multiple of 3? Well, let's look. We'd have 3, and then we'd have 6, and then we'd have 9, and then we'd have 12. So if we were listing multiples of 3, here would be a list of multiples. Is 12 on the list? You better believe it. So yes, 345 would be divisible by 3. So now let's look at 22. All right. So remember, if the sum, that's when you add the digits together. So I would do 2 plus 2, and that would equal 4. All right, well, let's look at our list. Nope, 4 is not on the list, so that would not be divisible, all right, by 3. So let's look at 21. We're going to do 2 plus 1. That equals 3. Is 3 on our list? Yep. So yes, 21 is divisible by 3. So 345 would be divisible by 3, because if you add those digits up, you get 12, which is a multiple of 3. And 21 is divisible by 3, because if you add 2 plus 1, you get 3, and 3 is a multiple of 3. Divisible by 4. If the last two digits of a multiple are a multiple of 4, or the last two digits are 0, 0, it is divisible by 4. So let's look here. All right. I have 24. Okay, well, I have 324, but I'm only concerned with the last two digits. Are the last two digits a multiple of 4? Well, let's make ourselves a little list. Now, this would be the same as making ourselves a T-chart. We're just kind of going sideways here to list out our multiples. So, but if you need to make a T-chart, just go right ahead. So we have 4, 8, 12, 16, 20, 24. Oh, there we go. We got to it. We got to 24. So are the last two digits a multiple of 4? Yes. So 324 would be divisible by 4. Let's look at 26. Now see, here it's a little tricky. The last two digits are the only two digits. So we have to look at that. Now we went to 24 on our multiples list, but we need to go past that. So the next one would be 28. Now, because it's 4, we did 24 and 28, and 26 would fall in between there. So 26 is not divisible by 4 because 26 is not a multiple of 4. Now if we come to the next number, 28, again, even if there's only 2 digits, that's enough. We look to see, are those 2 digits a multiple of 4? We look over at the list we just created. 28 is on the list. So yes, 28 is divisible by 4. All right, we're going to look at 3,700. We're going to look at the last 2 digits, which would be 0, 0. First thing we're going to do is look at our list. Does 0, 0 show up on the list? No, it doesn't. But there's a second part. See that or? The last 2 digits are 0, 0. So 3,700 would be divisible by 4. And I'm just going to do one more here. All right, so I'm going to look at the last 2 digits here. The only digit I've written down is 8, but it's nothing and 8, okay? Or I could even put a 0 there, but you don't need to. Does 8 come up on the list? Yes. So 8 is divisible by 4. Okay. Now here, this is one of the easier ones. Divisible by 5. Well, let's look at it. If the number ends with a 5 or a 0, it is divisible by 5. So let's look. What number does that end with? That ends with a 0. So if it ends with a 5 or a 0, so yep, 360 would be divisible by 5. All right, let's look at 742. We're going to look at the last digit. That's the only one that matters here. If it ends in a 5 or a 0, it is divisible by 5. It does not. So it is not divisible by 5. The next number, 85. We look at the last digit there, which is a 5. So remember, if it's divisible by 5, it ends with a 5 or a 0. Does it end with a 5 or a 0? Yeah, it ends with a 5. So yes, 85 is divisible by 5. Now, holy moly, here on the divisible by 6 rule, if it is divisible by 2 and 3, it is divisible by 6. So what I like to do, I like to start with a 2 because that's easier. Now remember the divisible by 2 rule, just if it ended with 0, 2, 4, 6, or 8, then it's divisible by 2. So let's look. Is 22, okay, so yes, 22 ends with a 2, so it would be divisible by 2. But now we have to see if it's divisible by 3 as well. So we look over at, what's the rule again for 3? If the sum of the digits is a multiple of 3, it is divisible by 3. So I'm going to add those two together. 2 plus 2, and that's going to equal 4. 4 is not one of the multiples I wrote down, okay, and I started below it and went past it. So that one would not be divisible by 6 because it was divisible by 2, but it was not divisible by 3. Let's look at this next one. All right, we're going to start with the 2 rule. We're going to underline the last digit. Is the last digit a 0, a 2, a 4, a 6, or an 8? What? That got a little close there, my bad. No, it is not one of those. So without even looking at the 3 rule, we know that it is not divisible. All right, well, let's look at the next one, 72. I'm going to start with the 2 rule. All right. Does it end with 0, 2, 4, 6, or 8? Yep, it ends with 2, so it's good so far. So now I'm going to move on to the 3 rule. I'm going to add the 2 digits together, and that equals 9. 7 plus 2 equals 9. Is 9 on my list for 3? Yep. So 72 is divisible by 6. Now I'm going to look at 114. All right, well, First thing we're going to do is see if the 2 rule works. All right, it ends with a 4. So is 4 on the list? Yep. So it passes that test. Now we're going to see if it's divisible by 3. So we're going to add together. I'm just going to come over here, a little more space. 1 plus 1 plus 4. 1 equals 6. All right. Is 6 divisible by 3? Yep. Or a multiple of 3. So yes. So 114 will also work. So now I'm going to come here. Pen too close again. My bad. Divisible by 9. If the sum of the digits are a multiple of 9, it is divisible by 9. So again, I'm going to add the 2 digits together. 7 plus 3 is 10. Well, I need to make a list of my multiples here real quick. Okay. 9, 18, 27. We'll just see if that gets us far enough. What it does for this one, 10 falls between 9 and 18. So 73 is not divisible. 846. All right, well, I'm going to add 8 plus 4 plus 6, 12 plus 6, 18. 18 is on my list. So 18 is divisible by 9. Here I have 45. I'm going to add those 2 together. 4 plus 5 equals 9. And it is on my list, so it is divisible. And if I just keep going a few more, all right, just look at the digits here. 9 plus nothing, well, 9 equals 9, because remember the sum of the digits have to equal 9 to be divisible by 9. 1 plus 8, well, that would equal 9. 2 plus 7, that would equal 9. 3 plus 6, that would equal 9. 4 plus 5, that would equal 9. So all of those follow the rule, obviously, because they're all the multiples. And divisible by 10. So the rule is if the last digit's a 0, it's divisible by 10, as long as the number is not 0. So like 60 would work, but like 65 would not work. 730 would work because it ends with a 0. All right, ends with a 0. Now, unfortunately, we did 2, 3, 4, 5, 6. If you notice, we have 7 and 8 missing. I'm sorry, but I don't know any good rules to share for knowing if a number is divisible by 7 or 8. So if you know those, please let me know and we can get those added in the video. But these are divisibility rules that can help you with your division, finding your factors, and working with multiples. So great little tricks to know so you don't waste time looking for a factor that may not exist. Thank you and have a great day.